Many times when we perform regression analysis, we'll see scoring of the model by accuracy, precision, recall, and F1. So what do these mean? In this video, we're going to take a look at how to evaluate classification results from regression using these terms. So we've made a model and made predictions, and the question is, how do we do? And that's what accuracy, precision, recall, and F1 will tell us. So as we typically do, we'll load the data, we'll study the data with graphs and summary tools like box plot and line chart and see, okay, are there outliers we need to take care of? Are there null data we need to take care of? Break the data into train and test. We train the data with the model, and then we evaluate the results of the model. And that's why we break it into train and test, so that we can train the model and then use the test data to put that into the model, see what the model predicts, and compare that to the actual results or the actual target that is in that test data. And that's what allows us to generate these effectively quality scores. So precision, recall, accuracy, and F1, easiest to see with a graph here. So precision. Well, first of all, let's take a look at the quadrant over here on the right. And this is something we can see in a correlation matrix when we're looking at our results. So if you take a look at the diagonal here, these are things that were correctly predicted. So remember, we're predicting it based on the test data. And the test data is real data that actually already has the target value, so then we simply compare to the target. So true positive means that we predicted this to be the case and it was the case. Either it was a Boolean true, or we said it was going to be a 3 and it was a 3. Now true negative says, okay, we said it was not a 3 and indeed it was not a 3. Or we said it was not true and indeed it was not true. So we correctly predicted the value in this diagonal here. Now false positive means we said it was a 3 but it was not really a 3. False negative says we said that it was not a 3 and indeed it is a 3. So this diagonal are the ones that we got wrong. So precision is the true positive over the true positive and the false positive. In other words, of all of the positives that we predicted, which is here in the denominator, what's the ratio of the actual positives to all of the positives that we predicted? That's what we call the actual results. Now recall, kind of similar, but we're looking at a different couple of boxes here. So precision is true positive over true positive plus false positive. In other words, this top row here. Where recall is true positive over true positive plus false negative. Now, we have to remember what a false negative is. It's something we said, okay, this is not a 3 or whatever the target value is. We said it's not a 3, but it actually is a 3. So we predicted it incorrectly as not being what we're looking for. Okay? So for recall, we're taking all of the items in the test data that indeed do have the target that we're looking for. So the true positive plus the false negative, so that's a sum of all of the items in the test data that indeed are positives. We make that the denominator. And the numerator is the true positives that we predicted. So, in other words, of all of the true positives in the test data, how many did we pick? Now, accuracy, true positive plus true negative divided by total. So, how many did we predict right over the total? So, precision, out of all the positive predictions, how many were correct? The range is going to be 0 to 1, and 1 or closest to 1 is the best. Recall, of all the positive cases, how many of the total positive cases were predicted correctly? Once again, a range of 0 to 1, closer to 1 is good. Accuracy, out of all the predictions, how many were correct? Ratio of 0 to 1, better be greater than 0.5. If it's less than 0.5, we predicted more wrong than we did correct. Now, F1 is a bit of a tricky one. It's a balance of precision and recall, and let's take this to the extreme. So if precision is true positive over true positive plus false positive, then the fewer false positives we have, the closer that number is going to be to 1. On the other hand, recall is true positive plus false negative in the denominator. So the fewer false negatives we have, the closer that number is going to be to 1. So think about that. What if we said, our model over-predicted the number of positives? Well, then that would likely help recall because we'd have fewer false negatives. More items would be positives. On the other hand, let's say that we maybe underdid things a little bit. Let's say that we didn't get as many positives as we should have. Well, then there's less chance of getting a false positive, and so the precision score is likely to be closer to 1. So you see, these kind of compete with each other. One of us wants to over-assume positives, and the other one wants to under-assume positives. So that's where F1 comes in. F1 uses a harmonic mean, which kind of put in simple terms is like the inverse of a relationship between two things. So it has a kind of funny notation here where it's 2 times precision times recall divided by precision plus recall. And it takes a fair amount of algebra to get there, which no need to explain that in this video and make this a very long video. But let's just say that F1 is a nice balance where recall and precision tend to compete with each other. Now, a confusion matrix is really easy to generate in Python, and it really reflects that quadrant that we saw earlier with the true positive, the true negative, and false positive. So true positive and true negative, false positive. So you can kind of get a good look at this, and generally we want this diagonal to be high numbers. We want this diagonal to be lower numbers. So that's a look at how we can evaluate our classification results. We'll see this will come in really handy when we're doing predictor selection, or in other words, feature selection, and we're trying to figure out which features will be the best for our regression model or our learning model, whatever model we use. And a lot of the algorithms that we have will try different combinations of features and then look at the output here, look at these quality metrics or maybe other quality metrics, and say, okay, well, I can use that information to eliminate the features that aren't adding to the model and then emphasize the features that are adding to the model. There's several different ways that we can optimize predictors, and having the knowledge here about the metrics that we look at will help to understand how those predictors or features get optimized. So as always, I hope you found this video helpful, and I look forward to reading your comments. Thank you.